Good day. Today we will talk about telecom networks. Telecom networks, that means the network that is used by telephones, and of course, nowadays by a host of other things, as we will discuss. This telecom network is very important in the sense that first of all it is one of the earliest networks that we had, that is one thing, that is quite old, and secondly the telecom network even today is mostly used for a wide area communication. Okay. We have, I mean, comparatively we have much fewer entirely or exclusive data networks. So, we will look at the evolution of telecom networks. Well, when Alexander Graham Bell developed the first telephone, it was a couple of telephone instruments connected by a wire. Now, if you are trying to connect more than one people, that means more than one subscribers are there. So, taking this principle forward, you will have to connect everybody to everybody else through a wire, which of course becomes very unwieldy very soon, okay, because connecting or stringing a wire between every pair of telephones that might want to communicate was not a good long term strategy at all. As you can see that very soon we have a veritable jungle of wires, and of course, it is it is costly and it is very difficult to manage. Even at the subscriber end, you cannot handle so many wires coming into your premise. So, a better idea was to connect all the telephones to a central switching office. There an operator could connect one telephone to another via a switchboard. Okay, that is the next figure that you see, that the number of wires have come down. As a matter of fact, in the figure at the top, if you have n subscribers, so naturally you have n into n minus 1 by 2 links, which is approximately n square kind of links, whereas in the latter case you have only n links. So, the number of links as n becomes large, and you know today there are so many telephone subscribers. So, there is no question of connecting them individually, you have to connect them to a central switching office. And when some subscriber A wants to connect to subscriber B, it goes via the switching office, and finally a connection is made. Excuse me. Now, in the switching office, in this system telephone user could connect to any other telephone in the town by cranking a handle. Okay. This was the old system. You know, in the old system, if you have seen some of the older movies or movies which is depicting an older time, okay, somebody would go to the telephone, lift it up and go with a handle like this, crank, 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 and what this would do is that basically this would ring some kind of a bell or some indication in the central switching office, and the switch was of course a person, okay, maybe usually a lady who would know that okay, this is the person who wants to talk to somebody. Then he would talk to that person and find out who it is or who is the subscriber to whom he wants to be connected. And when the subscriber tells that okay, connect me to such and such, so there would be through a wire, jumper wire, the telephone operator would connect this subscriber to the intended subscriber. Okay, that is how it would operate in the beginning, which of course is a rather difficult thing to do. Of course, nowadays it is not unbelievable that with today's teledensity we can handle it that way. That is so, after this role of the person was replaced by some electromechanical gadget, okay, and those exchanges were called Stoeger exchanges, and there is an interesting story about the Stoeger exchange. It seems that this person, Mr. Stoeger, he was an undertaker. So, you know, an undertaker who sort of prepares coffins for a person who has passed away, and it just so happened that there was another undertaker in the same town whose wife was actually the telephone operator. So, whenever somebody wanted to connect to an undertaker, naturally her husband would get the job. So, Stowager thought that was not good at all. So, he actually went ahead and designed some kind of electromechanical system. So, there would be relays and really mechanical switches which would go sort of rotate depending on what you have dialed on the other side and connect. And this electromechanical exchange served us quite well, I must say, and even maybe 15 20 years back in this country, you could go and see Stowager exchange is operating somewhere. But of course, nowadays those electromechanical things have been replaced by electronic switches, and the architecture also has become more complicated. So, we will come to this. So, this is how the switching office used to operate previously, that there would be an operator physically who would make a connection, who would make a physical copper connection through a wire from the caller to the callee using a jumper cable on a plug board, and there would be a connection between the two telephones. So, that is how it used to operate. Nowadays, we have a picture which is something like this. You can see that there is a local exchange building where there is a local exchange switch. The kind of signal that is used for this part, which is connecting the local exchange to the individual subscribers. Okay, by the way, this part is also called the local loop in telephone parlance. So, in the telephone parlance, so this still uses analog carrier systems mostly. Okay. So, and you see that there are two types of wires which are used over here. One is sort of connecting the premise of each individual subscriber to some kind of a housing, maybe some kind of a which is called a hut over here through a Cat3 cable. Okay. This is a thin kind of black cable which actually comes into your home. And in this hut, of course, so these cables are much thicker, maybe 50 pair or 100 pair kind of cables. So, to these Cat3 cables in this hut are connected to this. So, through this it goes to the local exchange where there is where the switching is done. And what is switching? Suppose this user wants to talk to this subscriber. So, there would be a switch over here between, because there are individual pairs of wires going from each subscriber to the local exchange, and the switch would connect these two pairs of wires somehow and they would get connected. Okay. So, this is the scheme. Now, it was I mean, of course, when as telephone developed more and more, naturally people found it very useful. So, it was soon apparent that callers did not just want to talk to people in the same town, but also to people in neighboring towns. Okay. Now, this was the next hurdle to be solved. Okay. The first one, you remember that the all pairs of telephones cannot be connected together. So, they all so every subscriber was only connected to the local exchange or the local switching office where individual subscribers would be connected. Now, if you have two different towns in two different locations, what would happen is that you cannot collect all of them to the same local exchange. Okay. This is a problem. First of all, from one town to another the distance would be quite large. So, irrespective of where you put your exchange, whether in this town or that town or somewhere in between, there will be a lot of wires which is involved, and naturally this is not feasible. So, what is required is that somehow these exchanges, so there will be a local exchange for this town and there will be another local exchange for that town, and these two exchanges have to be connected. Okay. So, this was the next step in telecom evolution. So, to connect every telephone in a number of towns to a single switching office was obviously impractical. So, the wires were too long. So, we came to the so called trunk exchanges. Now, what are trunk exchanges? Well, there are local exchanges, and then if a local exchange, if one local exchange wants to go through to another local exchange, it usually goes through a trunk exchange. So, this is a two tier hierarchy. So, there will be some trunk exchanges, and then each of the trunk exchanges would be connected to a number of local exchanges, and the trunk exchanges among would be connected between themselves, okay, in some fashion. So, automatic switching office of course enables connection in a fraction of a second. So, that means your connection request, well, if it is local, then the connection request is just served by the local exchange. Okay. That means, if you are just to want to make a local call between two subscribers who are under the same exchange. So, it need not go anywhere else. So, it will just simply be locally connected. If the caller and the callee are in two different under two different local exchanges, okay. Either the it is possible that these two local exchanges are connected, but the general scenario is that they would go to the trunk exchange and the trunk exchange would connect to the other local exchange, and then that local exchange would make the connection available to the callee. Okay. So, this is how connections are set up. Of course, I mean, as telecom grew bigger and bigger, you not only want to talk to the person in the next town, you want to talk to the person in the next state and maybe in the next country or a country around the world. So, that involves so I mean more levels of hierarchy came into the picture as we will see here. And so, soon customers wanted to talk to different regions, states and other countries. To cope with this, even more tiers were added to the hierarchy. To make a call, we now dial a number. This number is examined by the local exchange, which decides if it can connect you with local telephone or if it needs to connect you via a higher level switching office. So, that is this is the public switched telephone network that we have today or namely PSTN. So, this is a diagram showing something. Of course, this diagram does not show all. So, let us say at the bottom of the figure we have these individual telephones which are connected to the local exchanges, and the local exchanges may be connected to some trunk exchange, and these trunk exchanges may be connected to still other trunk exchanges and so on. And not only that, the picture is even more messy than it is shown here. For example, for some of the local exchanges would connect between themselves straight away. Okay. If there are lots of calls between two local exchanges, then the telephone company might like to connect a fiber between these two exchanges. Okay. For example, let us say in India, if you are making a local call, that is fine. Okay. If you are making a call which is to an exchange which is just adjacent, okay, then you would go through some connection between the exchanges. If you want to make an STD inside the same state, then this trunk exchange would somehow connect to that trunk exchange on the remote side. If you are going out of a circle, that means for example, West Bengal may be a telecom circle and then Bihar would be another telecom circle. Okay. So, the main trunk exchange of West Bengal would be in Kolkata and the main trunk exchange of Bihar would be in Patna. So, these two from Kolkata to Patna main tax exchanges, they would be connected through very high speed lines, and what would happen is that it will go from the subscriber to the local exchange to the local trunk exchange to the main trunk exchange at let us say Kolkata, and then to the main trunk exchange in Bihar, let us say in Patna, and then to further trunk exchanges, then further to the local exchange, and then to the final callee. Okay, something like this. And of course, if you have international calls, if you are making ISD calls, then you have to go through to still other hierarchy. That means, there are some particular gateways to which you will have to come before you can go out of the country. So, there is a question of routing a telephone call. Okay. Routing a telephone call, that means how do you find this way that from one exchange to another exchange to trunk exchanges to other trunk exchanges and finally to the destination, you have to make a connection. That means, for each of the switch on the way you will have to make some provision or some connection for this particular telephone connection. So, how do you find out? Okay. For example, a particular trunk exchange may be connected to a number of local exchanges and then a number of other trunk exchanges also. So, how do you know that which trunk exchange to go to next? Okay. This is the problem of routing, all right. And the routing, so you have to route a telephone call. So, in older telephone systems, when you made a call, the switching office set up a physical link called a copper path between your telephone and the callee's telephone. The way that the copper path is set up is called routing. In a telephone network, routing is usually straightforward, and I will come to the reason why. A call is routed up through higher level switching offices until it reaches a switching office that can reach the destination telephone by connecting with lower level switching offices. The switching offices examine the digits of the telephone number you dialed to make these connections. So, this is really in some sense fairly simple, in the sense that the way the telephone numbers are distributed in any country, in this country or in any other country, is in quite a systematic manner. Okay. For example, let us say if you are making an STD call in India, now if you are maybe, first of all, an STD call, you know that usually we start with the digit 0, all right. Now, digit 0 is not really a part of the number of the callee. Okay. Digit 0 is just indicating to the local exchange that this may have to be will have to be connected to some other exchange. Okay. This is not the exchange. So, that is some kind of an escape from this exchange to the to somewhere else. And but as I said that the telephone numbers are distributed in a fairly methodical manner. For example, after 0, if it comes 3, the digit 3 or say 33, you immediately know that this will be somewhere let us say near Kolkata, at least it will go through the Kolkata trunk exchange. Similarly, if it is 011, you immediately know that you do not even have to look at the other digits, and as a matter of fact, for a remote caller or to the remote exchange to which the remote caller is connected, the other digits do not make any sense, because they are really a number under an exchange which is far away. But it knows just by looking at the first few digits that that is the trunk exchange which I have to reach. Okay. For example, somebody making a connection from, let us say Kolkata to Delhi. Now, immediately you would know, suppose from Kolkata, so you will type in say 0, 1, 1 and then something. So, the local exchange would know that this is not only a trunk call or so called subscriber trunk dialing STD call. So, this will have to go through the main tax exchange in Kolkata in order to connect to that main tax exchange in Delhi. Okay. So, so it just makes the connection just by looking at those say first 2 digits, and after that whatever digits follow, they will be looked at by the exchange at let us say Delhi, and then the next few digits may indicate a particular exchange under in Delhi. So, it will look at the next few numbers and okay, decide that makes maybe 2 or 3 digits, and then decide okay, that is the exchange to which it is connected. So, it is immediately routed to that exchange, and that exchange will look at the last few digits maybe and know that okay, this is the subscriber. So, the connection would be made. So, routing, so you do not have to really have to search around in the entire country to find out where this number belongs to. Just by looking at the numbers, looking at the digits 1 or 2 at a time, you can find out that what is the next step that that the connection has to take. Okay. So, this makes the routing problem easy, unlike some other cases which we will get to later on, but for telephone the routing is fairly straightforward. So, it looks at the digits and makes up the connection. So, and one point is that we are already always talking about connections, because essentially telephone service is a connection oriented service. What do we mean when we say that telephone service is a connection oriented service? It means that usually okay, this is sort of changing somewhat a little bit, but the overwhelming major portion of telephone connections, they are still connection oriented. So, in a connection oriented service, what happens is that a dedicated connection between the endpoints are maintained throughout the session. Okay. So, when you are actually calling, so during that time by looking at the called number, the path will be set up, and at each point, at each switch, there will be a, let us say at the moment, let us assume that as if there is a physical connection. Okay. This connection may not be a physical connection, this connection may be some kind of a virtual connection, but for our purpose at the moment let us assume that they are physical connection. So, there is a physical connection at each switch. So, there is a continuous path from the source to the destination, from the caller to the callee, and this path is maintained, is held reserved in for this particular session during the entire session. Okay. This is not shared with anybody else. So, if that is so, this has a number of advantages. Okay. So, usually it means that the quality of service can be reasonably guaranteed to the extent that the bandwidth for the channel that is established. That means, this whatever bandwidth this channel might be having, this is exclusively for this particular call, for this particular session. So, there is no contention for bandwidth by a multiple users. Okay. Usually we are talking about just landline phones for the time being. So, that is why, so if that is so, first of all if the bandwidth is held constant, so the quality of service is good. Second thing is that since the path, actual path is held constant, the message bits arrive in the same order in which they are sent. Okay. By the way, please note that this always need not be so. For example, if this path was not reserved and held constant for a particular session, that means if some part of your call is going through one path and some other part of your call is going through another path, then later bits may arrive earlier depending on what these two paths are. Okay. So, such a thing would not happen in a telephone connection usually. So, message bits arrive in the same order. So, these are the advantages of having a connection oriented service. So, traditional telephone circuit is a circuit switched, that means actual physical connections are made, connection oriented system. The downside of this is that it is less efficient use of the total available bandwidth. The reason that this is a less efficient use of the total available bandwidth is that I mean there are, whenever we speak, there are, for example, I mean this is just one of the factors, there are many other factors. For example, when two people are speaking, there are considerable periods of time or epochs of time during which nobody is speaking. Okay. So, at that time the channel is lying idle. Okay. Remember, this particular channel that has been set up for one particular call is held constant during the duration, during the entire duration of the call. So, at that time nobody else can use it. So, this is one source why this is a sort of inefficient use of bandwidth. Another problem that came across, and this is actually a very serious problem, this happened due to historical reason, is that these traditional telephone equipments tend to be more costly. Okay. Now, why is that so? Well, the reason is that this telephone system and the way the switches etc. were designed, at least earlier, so they had a long history, all right. And naturally in this particular field the rate of development of technology is very high. Okay. And the next generation of technology would always have a tremendous cost benefit advantage compared to the previous generation of technology, all right. So it so happened that the computer technology started leading the technology race. If of course, it does not mean that the traditional telecom technology stayed in only at one point. Okay, this was also evolving. Okay, and the computer communication, that field was also evolving, but it so happened that some competing technology, which is the so called connection less service. So, we have been talking about connection oriented service in telephone. So, in the connection less service, it always it quite often has the advantage of using the next generation of technology, making it much cheaper, all right. So, this proved to be a great hindrance to the traditional technology in telephones, and that is why many of the most of the traditional service providers are slowly now, or slowly or fast depending on how agile they are moving to this new technology, which essentially sort of sprang from another field. So, and that is the so called connection less service. Now, what is a connection less service? In a connection less service are packet by packet. This is not over the entire session. One packet of data on that particular data may be containing voice data. Okay. So, one particular packet is sort of thrown into the system and routed independently of all other packets. So, as we had seen earlier that this first of all this means that you have to have the destination address at each packet, okay, that is one thing. So, if you have the destination address in each packet, maybe you can route it fast enough to reach the destination, and the next packet from the between the same caller and callee, mind you, will come as another packet. It will also have the same destination written on it. And it may so happen that some router in between is going to route it in a different path. Okay. So, this connection is not held constant like the connection oriented service. Here this is a connection less service, it is packet by packet service. Okay. So, this has some disadvantages also. For example, I mean one reason is that one thing is that some of the lines may be good, some other lines may be bad, and some of the packets may get dropped in between, that is one thing. Secondly, what might happen is that a packet which had been sent later may through a different path arrive earlier at the destination. So, all these problems are there in a connection less service, but the major advantage of connection less service, one major advantage is that it is cheaper. Okay. It is cheaper firstly because it is somewhat more efficient than the traditional circuit switch systems, and secondly it is usually more efficient because it usually tends to use the more recent technology in terms of silicon, in terms of IC, etc. So, it has a higher volume, so its pricing is lower, okay. And that because it is lower, that is attracting all these other telephone service people also into this technology, and there is a definite shift towards this kind of technology. Okay. By the way, you can take special care to guarantee that to the receiver the packets are received the packets are correctly received by the final recipient and in proper order, but you have to put in some extra effort for that. So, we will look into this later. As mentioned earlier, each packet must contain the source and the destination address in order to be routed. IP networks are based on packet switching technologies, so that this is what most computer systems what use. Special techniques are employed to get some guarantee about the quality of service. The technology being cheaper, it is beginning to dominate all networks. Okay. So, traditional networks as well as the current networks. So, so this is the by the way, even then once again I mentioned this earlier in the lecture, you must remember that it is not that we have a whole parallel network for data from computers etc., all over the globe. Okay, it is not there, because the telecom network has been around for a long time. It had a long and very excellent history. So, that is why even today most of the wide area network traffic is still rides on this telecom network. Okay. So, we have a lot of, so originally it might have been a packet, then it might be sort of made into some kind of a session for which there is some part of the connection is dedicated. So, all kinds of technology has come in, but even today most of the wide area networks are based on the telecom networks, and telecom. So, that is one side of the story. The other side of the story is that telecom networks, the telecom people are actually in the process of routing some of the voice calls and maybe some of the other kinds of calls into this packet kind of technology. Now, about the transmission media in telephone systems, we have already talked a little bit about it earlier. So, I will not go into the details. In traditional analog telephone systems, the telephone is connected to the local exchange via Cat3 UTP cables. We know what they are. So, this connection is called the local loop. It is typically between 1 kilometer and 10 kilometer in length. Higher up in the hierarchy, higher bandwidth cables are used to carry multiple telephone calls. This is far cheaper than using separate cables for separate calls. Specifically, digital lines on fiber is used, and analog systems used a technique called frequency division multiplexing to do this. Nowadays, of course, time division multiplexing is the most dominant standard. So, if you remember the earlier figure we had, that we have this local exchange. So, your a particular subscriber would be connected to the local connection hut, maybe through a Cat3 cable. From that hut, a fat cable would usually run to the local exchange, and this fat cable in most cases today are still basically a collection of pairs of cables. Okay. So, they are just in one sheath. So, that is why that is a fat cable. So, physically it is fat, and maybe there are 50 pairs of cables or 100 pairs of cables. So, if there are 50 subscribers coming into a hut, they can be connected through individual pairs in this bunch of pairs of cables that run from the hut to the local exchange. So, you may say that up to the local exchange we have these pairs of copper cables running. Okay. Now, but once you go to the exchange level and beyond, that means then higher up in the hierarchy, like to the trunk exchanges and so on. So, there of course, you need to carry a lot of calls, So, and usually this connection is through fiber. Okay. So, there all kinds of multiplexing techniques, and but specifically time division multiplexing, which is the dominant one, some specific versions of time division multiplexing which we will see later. So, this kind of multiplexing is used, and a large number. So, today a fiber may easily carry you say 1000 voice calls or even 3000 voice calls just on a fiber. So, that is no problem at all right. So, so that naturally for example, think of a connection between let us say two big cities, all right. So, a lot of subscriber pairs from both sides would want to talk to each other at the same time, all right. So, that is the great thing about this fiber, because they can accommodate a large number of channels. So, it has got a huge bandwidth. So, they are connected through fiber, and all these calls are sort of multiplexed, maybe in a time division multiplex fashion, which goes to the other end, gets demultiplexed, and finally fed to the local loop, which again are individual copper pairs. So, the subscriber handsets, and that is the we are now talking a little, just let us take a little look at the local loop. The subscriber handsets are powered by a battery bank in the exchange. Okay. I mean at least the ordinary handsets, you know that the ordinary handsets you do not need to connect it to any power, it actually derives its power from the same cable which is coming and connecting your telephone set. And with echo suppressors the transmission is half duplex, and with echo cancellers it is possible to have full duplex communication. Okay. So, this is if you remember we talked about half duplex and full duplex communication. Half duplex communication means that the communication can go in either direction from this side to this side or from this side to this side, A to B or B to A, but then only in one direction at any one particular point of time. Okay. So, at some point of time A may be connecting to B or A may be transmitting to B, and then A will become quiescent and B will be communicating to A through the same line. This is half duplex communication. We require some kind of echo suppressor for this, because otherwise we will be hearing your own voice, which is really very irritating. There is a way of echo cancellation, and it is possible to have full duplex communication on the same line. Okay. So, that is also done. Since the local loop is still analog, we need modems for sending digital data. Okay. That this local loop being analog has quite a bit of implications. One of the implications is that when you try to communicate digital data over it, and we are talking about this telecom network in the context of computer networks, but if you want to connect a computer network to your local loop, so your computer produces digital data. So, they have to be modulated and demodulated. So, modems always come in pair for sending the digital data. Since 1 bit is used for control purposes, we usually get 56 kbps speed on a on this local line. You remember that the computer lines are designed to handle 64 kbps. Okay. 64 kbps is the basic rate for communication purpose. If you remember that we have this 4K bandwidth which has sampled at double the rate, which is the Nyquist rate, that is 8 kilo samples, 8 bits per sample for indicating the level of the or the intensity of the signal. So, we have 64 kbps. So, this line is really designed for 64 kbps. When you are sending computer data over it, so you are using a modem, and this modem pairs etc., they need to communicate with each other, and there is some 1 bit is used for control purpose. So, finally, we get a 56 kbps speed. So, that is why nowadays almost everywhere you will see that the modem 56 kbps modem, people talk about a 56 kbps modem. So, that is where this particular figure comes from. Okay. But of course, although you may be having a 56 kbps modem, this may not always be I mean you may not always get a 56 kbps speed, because depending on the line condition, maybe some of the connections are weak etc., or it is noisy, so it is picking up a lot of noise. So, depending on that, the two modems will automatically negotiate a lower speed, and in actual practice you might find a lower speed for your computer communication. Okay. And just one other point before I go to signaling, I want to mention that another implication of having fully analog technology in the local loop is that I mean on an analog signal you I mean before you can use TDM or other kinds of multiplexing techniques higher up in all those between for connecting between exchanges etc., you need to convert it to the digital signal over there. Okay. So, an exchange usually will have a bunch of codecs. Okay. Codecs for coders and decoders, and there are various coding and decoding standards, but anyway, so it will have a bunch of codecs which will convert the analog signal which is coming through this local loop into a digital signal, and then now this digital signal is ready to be multiplexed with other digital signals to reach its final destination. Okay. Now, a little bit about signaling. Okay. this is a rather quite a vast area. So, we will just be touching it. So, we will just mention some names and basically what the signaling is. This is what I will try to give an idea over here. Signaling refers to the information exchange between terminal devices, exchanges and routers for setting up circuits, termination, billing, advanced network services, etc. Okay. So, once again what it means is that when you are making a telephone call, of course, what you are finally, suppose you are making a simply voice call. So, finally, what you are interested in is that your voice should be audible to the callee on the other side and his voice should be audible to you. So, this voice should communicate. So, that is the main communication which is going on through this channel. But in order to achieve this, okay, all the intermediate nodes, and these intermediate nodes, that could be your local exchange, that could be trunk exchange, that could be sort of switches in between, there will be routers and multiplexers. So, all kinds of things will be there in between, all right. Now, they have to get some information and then need to exchange some information in order to basic setting up of the line. Now, apart from basic setting up of the line, you need other kinds of services. For example, of course, from the service provider side, you need to bill a person. Okay, if he is making a call, you want to bill him, and depending on whether he is making a local call or whether he is making an STD call or an ISD call, you may bill him at different rates. Okay, so that is one. So, billing is another kind of thing. So, it has to know that what kind of similarly, for making the connections, you have to capture those digits, and those digits have to be fed to the particular exchange. It may be computers, routers, switches, etc. So, they have to be fed over there in order to make the connection. So, all this is a part of signaling. Apart from the actual transfer of, let us say, voice, or it could even be data, but whenever you want to set up some call and take some service, some signaling will always be required. So, there are various types of signaling systems, but it is sort of converging to some standards. In common channel signaling, which is in band, by in band we mean that the same bandwidth which is used by the voice is used by the signaling also. So, why does not it interfere with voice? Well, what is done is, first of all, usually this signaling would be suppressed even if they go on during the call, but usually most of the signaling is done before the call is set up. So, common channel signaling works very fine. Some of the bits in the frames is used for this purpose. Okay. So, that means that finally, even your analog signal is converted to digital signals, and you make a frame out of it, and in this frame you could stuff this frame with some extra bits for this control purpose. So, SS7 signaling system 7 is a widely accepted standard, and this is almost I mean slowly spreading. This is a complex standard, but this is slowly spreading now. Now, whether in band or out of band, logically the switch controllers may be considered to be an overlay network in the control plane. That means that you have all these switches through which the actual connection is taking place, but then you have some switch controllers. Okay. These switch controllers will actually give instructions to this switch to switch in a particular fashion, maybe, or maybe do some billing or whatever. So, these switch controllers. So, there is a network of switch controllers. First of all, there is this network of subscribers. Okay. Subscribers are connected through this maybe their voice set or maybe through modem, etc. All over. So, that is the primary service giving network, but overlaid on this, on the same network, you have these switch controllers at various points who are talking to each other for giving all these services, and they are using the same network. So, this is some kind of an overlay network over the basic network that we have. Okay. There are all kinds of extra services are being given these days. For example, you know that nowadays wherever I mean SS7 or any other advanced signaling system is there, you can get the caller ID. Okay, that means if your local exchange supports it, that means whoever is the caller, his ID, that means his telephone number will appear in your handset, so that you even before you answer, you know that who is it that is calling, and then you may choose not to answer him or whatever. Anyway, you can make a note of it. Now, how is that done? Because his numbers that he used, he dialed at his end, and that is how the circuit has been switched set up. And not only that, the source number, because the local exchange has to know the source number. So, the source number is also transmitted and finally fed to the receiver end, so that he gets the caller ID number. So, all kinds of intelligent services are being given these days. So, this is the signaling system 7, and there is an out of band signaling which is the different from in band signaling, which is that means in out of band, that means for the signaling purpose a separate channel is always earmarked. So, they do not interfere with this regular channel at all. Okay. So, this is more flexible, at it allows arbitrarily complex message transfer. So, this is a state diagram of, I mean just a very quick look, I mean and a very rough diagram of the kind of states that the system goes through when a call is being made. First of all, it is quiescent, that means it is not doing anything. Then you pull the take the receiver off hook. Okay. And nowadays, of course, telephone services have improved tremendously. Otherwise, you would have noticed or in some times even today you may notice that with the moment you take it off hook and the moment you get the dialing tone, there is a there may be a gap. Actually, these two are not the same thing. You pull it off the hook, which gives a signal to the local exchange that you want to maybe make a call. Okay. And then the local exchange then finds some resource to serve you, and when it finds that resource to serve you, then it gives you a dial tone. So, dial tone, when you get the dial tone, you know that local exchange is ready to receive the numbers that you would dial. Okay. So, then you will dial some numbers, then you will have to wait for some time for the call to be set up. Now, if it is simply a local call, it may be set up in a small fraction of a time. If it is an call to a if it is a long distance call, you might have to wait for some time, for some appreciable time when the call is being set up. And when the call is set up, so of course, there is the handset on the other side starts ringing, but that is not the ring that you hear. You get a when the local switch knows that the entire path has been set up, it sends a signal which comes as a ringing noise to your phone. So, you know that the other side of the line must have been set up, and then they start talking. If the other side will also go off hook, and then they will start talking, and then they will disconnect, and at the time of disconnection you want to know that how much to bill this person, etc., etc. So, we will quickly go through this control plane protocol stack of SS7. I will just mention some names, for example names of some elements. You know that this is a very huge area, this software development for telecom. So, these are some of the elements which are there in SS7. For example, application service element, that is application level functionality such as interpreting signaling messages. Then there are transaction capabilities which allow systems to invoke procedures calls on remote machines. Then signaling connection control part, the SCCP. So, it connection, sequence numbering, segmentation, reassembly, flow control. So, some of these terms may not make any sense at the moment. So, we will discuss these later on in other contexts. Then there is a message transfer part 3, part 2 and part 1, and then one of the main applications of SS7 is the telephone user part, which is responsible for setting up voice calls. The TUP interprets the dial digits, routes, reserve resources and maintains accounts, etc. Now, just quickly on the digital technology in the telephone networks, okay, as mentioned earlier, that traditionally everything was analog, then the exchanges started getting converted to the digital technology. So, what you do, a device called a codec, as I mentioned, is used to convert analog voice signals into digital information that can be handled by digital technology. The codec is also used to convert the digital signals back into analog on the other side, so that voice signals that can be handled by the older analog technology. Now, most of the telephone network is digital, only the local loop is still mostly analog. There has been attempts to make this digital also, and one of the attempts was this integrated service digital network. So, the so called ISDN. So, let us take a quick look at ISDN. ISDN was envisaged as an end-to-end digital service. That means, it starts as a digital service from the user premise and goes straight that way as digital service right to the other end. Now, home users would be connected by the same Cat3 cable. That was important, because these Cat3 cables are already, people were already connected by Cat3 cables, and if, so it is a very difficult and costly proposition to change all that cabling. So, the idea was to use the same Cat3 cable for this new digital service. So, the same Cat3 cable. So, there will be some kind of a termination, network termination on the end. So, there were two rates, one was a basic rate, which was a 2B plus D or 144 kbps. 2B means two voice channels of 64 kbps each. So, that is 128 kbps, and one D channel, that is for the control purpose. So, you could do out of band signaling over here of 16 kbps, giving you a total of 144 kbps, that is the basic rate for ISDN. For higher users, you have a primary rate equivalent to E1. So, there are 30 channels for this, maybe voice channels, and one D channel etc. for an E1 line, something else in USA that we will see later. The system uses out of band signaling and uses the D channel for that. NT1 is the network terminating device, which connects to the ISDN exchange on one side and local passive bus on the other. For users who have larger users, you have another kind of termination called NT2. The ISDN turned out to be very expensive. This was a problem. ISDN was originally envisaged that this is all give very broadband service, voice, data, everything on this same ISDN, but unfortunately, because of historical and technological reason, the ISDN turned out to be quite expensive. So, although they were deployed in some places, they also deployed some places in India, and they are deployed more in Europe, but then since it was so expensive, it did not become popular. So, that was the problem with ISDN. So, people thought about a new technology altogether called ATM, and we will discuss ATM later. Another direction in which this digitizing the local loop went was the digital subscriber loop or DSL. So, this large user, one of the it had two basic approaches. One was that for a large user, let us say a particular office or a company, you can take a fiber to the premise of that company, and then I mean you can, which is an integrated sort of outlet, and you can give him all kinds of services. That is one thing. The other is to use the same Cat3 cable, okay, maybe different bands of it, using some advanced technology of multiplexing signals, and then give both data and voice at the same time on the same line. So, you have this remote subscriber terminal which is connected to the individual users. So, the copper twisted pair remains the same, but the new equipment is integrated, enabling a service provider to deliver voice and high speed data service at the same time. So, this is a picture. That means, you have a subscriber who are connected through that analog and DSL line. Now, in the on the central office side, what you have is you have some kind of a splitter, okay, and in the with the splitter, one side is the data, one side goes the data through this DSLAM, that is and digital service access multiplexer. So, that goes, and that goes maybe to the internet. The other part goes through the voice switch to the PSTN, that is the other plain old previous voice services. Okay. So, DSL at subscriber and voice traffic is transmitted as standard analog telephony signal. Data traffic is transmitted over the same line but via DSL modem that transmit data as high frequency digital broadband signals on the same line. Okay. So, if you have DSL modem, you can have both your voice as well as data at the same time, unlike very ordinary analog lines. So, DSL at the central office end CON, the signal passes through a splitter as I had shown and a local loop management system. So, the subscriber line access multiplexer is there. So, this figure we have already seen. So, you can just have this figure. So, you have this DSLAM and the loop management over there. So, the broadband digital signals are directed to a DSLAM that terminates and coordinates traffic from multiple local loop lines. From the DSLAM, the traffic is sent to a router and then to the internet. Okay. And finally, we have the loop management system, which may be in front of the splitter or behind the splitter. So, this comes to various functions are there like giving the connections and testing and all these service kind of these things are done through the local loop management. Thank you. Good day. So, today and in the next lecture we will be talking about switches. Switches are the most important part of computer networks, and we will just look into some aspects of the different types of switches. So, first in this lecture we will start with the kind of switches which are used in telecom networks. Okay. Then there is a special version of these which we will cover in a later lecture, and then in the next lecture we will be talking about packet switches which are closer to the heart of data networks. So, we talk about switches. First thing is, why do we need switches? Well, the problem is that each user can potentially call any other user, as we have seen in telephone networks. So, and we cannot have direct lines, we cannot have order n square kind of lines. So, every user is connected to essentially a switch in the switching office, and switches establish temporary circuits. That means, they establish a temporary connection between the caller and the callee at the switching station, and switching systems comes in two parts. One is the switch and the other is the switch controller. You see, as this fellow says 000 wants to talk to 0001. So, he will simply go like this, and similarly another line over here may want to go straight down to somewhere over here. So many calls can go through together, but this is not always the case. Okay. This is not always the case, as there may be contention for the same switching element, as we will see in this diagram. You know, because if you produce something in very large number, you can amortize the cost of its development etc. over a large number of switches. So, this cost of the switch comes down. So, Ethernet switches have become very cheap these days. Okay. A switch which used to cost maybe a lakh or so, maybe 10-15 years back, costs only a few thousand rupees today. So, this is the most common type of switch which we see everywhere.